All right, guys, picking back up, number 58 is a related rates question. So these ones are generally, I think, a little easier. So we're going to go ahead. Number 58, changing area. The radius of a circle is changing at a rate of -2 over pi meters per second. So radius is changing, which tells us it's dr dt, -2 over pi meters per second. And this is really, the units are really just to help us with our answer at the end. We want to know at what rate, so we want to rate, dt, is the area changing, dA, when r equals 10, specifically meters. Okay, perfect. So let's go ahead. We're going to write the only equation that I know that relates A to r, and that is that A is equal to pi r squared. If you're only two variables in it you have information for, like dA dt we want to know, and r dr dt we know, you can go ahead and take the derivative with respect to time. So the derivative of A is dA dt. The derivative of pi is just a number, so a number times r squared. We bring the 2 down, 2 pi r dr dt. And then we go ahead and plug everything else in. dA dt, which is what we're looking for, 2 pi r, well r they want to know when it's 10, so we got 10. dr dt is -2 over pi. All right, let's cancel what we can. Pi and pi, 2 times 10 times -2 is, I believe, -40 dA dt. We need to put some units on this. Radius was meters per second, so this is going to be per second, but it's area, so it's meters squared per second, which tells us that the area is decreasing at -4, at basically at 40 meters per second. All right, next related rates problem, changing cube, 60. Okay, the volume of a cube is increasing, so volume dV dt is increasing at a rate of 1,200 centimeters cubed per minute. At the instant its edges, so an edge, or basically that's a side, is 20 centimeters long, we want to know at what rate is the edge changing. So dE dt. Okay, so let's write an equation that relates volume to edges. So if it's a cube, right, and all of the sides are the same length, in this case they're all, oh, I cannot draw a cube apparently. There you go, if they're all E, right, volume will equal E cubed, E times E times E. So dV dt will be 3E squared dE dt. Fill in everything you know. 1,200 equals 3 times E, which they're going to call us as 20, dE dt. So we can divide by 3 straight away. So we got 400 is 400 dE dt, because I'm pretty sure 20 squared is 400. And so that means that dE dt is just going to be 1. And our unit of measurement we're going to get from our volume, it's just centimeters. 1 centimeter per minute. All right, last problem is 62. And this is a cone problem. We love cone problems. I want to make sure you can do a cone problem. So make sure you can do cone problems. Okay, we've got water draining from a conical tank shown in the figure. So here's our conical tank. It's always upside down. It's draining. They tell us that the original height of the tank is 10. They tell us that the original radius is 4. Okay, all right. And they want to know the relation between the height and the radius. Okay, so the height and the radius. Let's do this. So we had done this, and it was always really easy. If you're not sure what percentage of 4 is, you can always make a ratio that r to h is 4 to 10. So if we just cross multiply this, we get that 10r is 4h. Divide both sides by 10 and we get that r is 4h over 10, which is the same thing as if I divide these both by 2, we got 2h over 5. So r is 2/5 of h. In the same respect, h, if you really needed it, if we wanted to use the reciprocal of this, h would be 5 over 2 times r, or 2.5 r. All right, we're going to use this because we want to know how fast is the water level dropping when h equals 6. So we want the water level, how fast this is dropping. So we're looking for dH dt. So let's get an equation. We got volume is pi r, basically 1/3, or pi r squared h over 3. That's 1/3 pi r squared h. And we want to know dH dt. So we are going to try to get rid of the r's so that we only have h's left over. So we're going to take this, plug it in here for r. So we've got pi over 3 times 2 over 5h squared times h. So I'm still working on the volume equation here. We got pi times h squared times h times 2 squared. So that's 4 pi h cubed over 3 times 5 squared, and 5 squared is 25, so 3 times 25 is 75. That's our volume. Okay, we only have h in our volume, which means now I can go ahead and find dV dt. And that is going to be, so we're going to bring down the 3. So we've got 3 times 4 pi h squared dH dt all over 75. And now we're going to plug in everything else we know. We know that water is draining from the conical tank at a rate of 5 feet per minute. So basically, that's the change in volume, -5 feet per minute. Cubic feet per minute. And then, so we're going to solve this. 3 divided by 75 becomes 25. So we've got 4 over 25 pi. H, they're telling us when h is 6. So 6 squared is 36. dH dt. I'm going to go ahead and just get rid of this. 4 times 36 is 120, 144. So that's 144. So we're looking at -5 equals 144 pi over 25 dH dt. So to get rid of all this in one go, I'm going to multiply by the reciprocal. dH dt is -5 times the reciprocal of this, 25 over 144 pi. And we go ahead, 25 times -5, -125 over 144 pi dH dt. And that's our answer. All right, guys, good luck studying. And honestly, focus on your cones, some right triangle problems. We didn't do any of those, but we did tons of those. And I'm going to get the answer key scanned today. All right, bye.